All right, so let's jump right in. You've done it. Your machine learning model is live, it's out in production, and it's making a real impact. But what happens when things go wrong? Today, we're talking about building that essential safety net, a really robust alerting system for your ML models.
So, just picture this for a second. Your model is out there in the wild, doing its job. But then, quietly, without any warning, something breaks. So what does that actually look like? Well, for one, its performance could just completely tank. All of a sudden, the predictions it's making are just not reliable anymore. Or maybe it just gets slow, like really slow. Your users are stuck waiting and the whole application just grinds to a halt. And the worst case scenario, it just goes dark. It completely stops responding, leaving a critical part of your business totally non-functional. And the scary part, if you don't have alerts, nobody even knows it's happening. And that really gets to the heart of the problem, doesn't it? This quote, it says it all. The biggest threat isn't the failure you can see coming. It's the one that happens in silence. Because by the time a human finally notices, the damage has already been done. So, here's what we're going to cover in this explainer. We'll kick things off with the danger of that silence. Then we'll introduce your first line of defense. We'll cover the key metrics and tools you'll need, see how to go from just detecting a problem to actually taking action, and we'll wrap up with some crucial rules for building a system you can really trust. First up, let's really dig into this danger. The high cost of not knowing, it's about way more than just a broken model. We're talking lost revenue, seriously frustrated users, and a total loss of trust in your entire system. These silent failures, they undermine everything. So how do we fight back against this kind of silent threat? Well, we build something that listens. Let's introduce your first and, frankly, most important line of defense, the ML alerting system. At its heart, it's a pretty simple concept. Think of it like an automated watchdog. It's constantly monitoring your model's health and its behavior, and the very moment something crosses a line you've defined, it sounds the alarm. It automatically notifies the right people so they can take action. And this is where it gets really practical. Look at this. This is all about translating those abstract problems into concrete machine-readable rules. So, if the data distribution changes and the Population Stability Index, or PSI, goes above 0.2, boom, you get an alert. If your F1 score, which is a key measure of your model's accuracy, dips below your quality standard, you get an alert. If your response time creeps past 150 milliseconds, you get the idea. It's all about defining what failure looks like before it happens. Okay, so we get it, we need to set rules. But what exactly should we be watching? Let's move on to the key metrics your system absolutely needs to have its eyes on 24/7. See, a truly great system looks at the whole picture. It's not enough to just track model performance like accuracy. You've also got to track its operational health, things like latency and GPU usage, because let's be real, a slow or overloaded model is a broken model. You must watch for data drift using statistical tests, because if the real world changes, your model's old assumptions might be totally wrong. You've got to check for data quality issues, since we all know garbage in, garbage out. And please, never forget the business metrics. A model can be technically perfect, but completely fail to drive revenue or clicks. And at the end of the day, that's the ultimate failure. Great, so we know what to watch. But how do we actually build this thing? Let's open up the MLOps toolkit. That's the whole set of practices for reliably deploying and maintaining machine learning in production, and take a look at the tools for the job. And wow, there's a whole ecosystem of tools out there, right? For real-time metrics, Prometheus and Grafana are the absolute titans of the industry. For really sophisticated drift detection, you have these specialized libraries like Evidently AI. If the signals you need are buried deep in logs, the ELK stack is your best friend. And of course, for getting those alerts to actual humans, you've got on-call systems like PagerDuty and simple direct channels like Slack. But while there are tons of options, the powerful and super common setup you'll see out in the wild most of the time is this classic trio. Prometheus scrapes and stores all the metrics, Grafana builds these beautiful, intuitive dashboards to visualize everything, and then Alertmanager, which is part of the Prometheus ecosystem, pushes the final alerts out to a Slack channel. And check this out. This is a perfect example of just how simple and powerful a rule can be. This one little line of code in Prometheus is basically saying, hey, watch the metric called model latency seconds. If its value goes above zero point 0.2, that's 200 milliseconds, and it stays there for 1 full minute, then and only then fire an alert. It's declarative, it's powerful, and it stops you from getting spammed by alerts from tiny, brief spikes.
Okay, so now let's zoom out a bit and see how all these individual tools and rules actually fit together. Let's take a look at the full alerting architecture, from the moment a problem is detected to the moment an action is taken.
You can really think of it as a 4-step pipeline. First up, you have the monitoring layer, with tools like Prometheus or Evidently just collecting all that raw data. Second, the alert processing layer, which is usually Alertmanager, applies the rules we just talked about. Third, the notification layer, sends a message out to the team. And fourth, and this is where it gets really powerful, you can have an automated action layer using tools like Airflow that actually triggers a self-healing process, like automatically kicking off a model retraining pipeline. But here's the thing. Not all alerts are created equal. A slight dip in accuracy is a very different problem from the model being completely offline. That's why categorizing your alerts is so important. Is it a critical, system-down failure that needs to wake someone up at 3 a.m.? Or is it just a warning about potential drift that can be looked at in the morning? Getting that context right is the key to avoiding alert fatigue. All right, we've gone through a ton of stuff, so let's try to boil this all down into some clear, actionable rules for building a reliable alerting system. We'll cover both the best practices and the common mistakes you really want to avoid. Okay, on one side, you have the path to success. This is about using those severity levels we just talked about. It's about making sure every single alert is actionable. It has to tell you what broke, why it broke, and maybe even suggest what to do next. And please, for the love of all that is good, test your alerts. Then on the other side, you see the common pitfalls. Drowning your team in noisy, low-value alerts is the fastest way to get every alert ignored. Sending cryptic messages with no context is just useless. And if you're only relying on manual fixes for everything, your system is just not going to scale. And really, this quote just nails the whole mindset shift we're talking about. A reactive system, it just sits there and waits for a user to complain. A proactive, modern ML system actually anticipates failure. It's designed not just to detect problems, but to react and often to heal itself. So at the end of the day, what are we really saying here? An alerting system isn't just some add-on or a nice-to-have feature. It is the very heartbeat of your production ML system. It provides that steady, constant rhythm of information that tells you it's alive, it's healthy, and it's doing exactly what you expect it to do. And that really just leaves one last question for you. Think about the models you have in production right now, or the ones you're building. Without a proper alerting system, they're operating in total silence. So, is your system ready to listen?